All right. Hi, everybody. Last session on Wednesday, right before Ask the Experts. Thank you all for coming out. I want to give a shout out to our friends in Siberia back there. It's warm up here. You can come forward and hang out. My name is Ben Canning. I'm the group program manager of the SharePoint data center team. My team's job is to run the service fabric that makes SharePoint Online come alive and work for all of y'all. I'm going to give you sort of a behind-the-curtain tour of the data center and how we run the service today. It's a big room, but I'm hoping this will be sort of a chalk talk where I'm going to touch on a bunch of different topics. And if you've got questions, please just shout them out, and we'll go through them. So I wanted to start off talking a little bit about, sort of SPO by the numbers. When I was here at the Mandalay Bay 3 years ago for the last big SharePoint conference, SharePoint Online was kind of a glimmer in our eye. We had BPOS, but that was a little bit smaller, and we had the dedicated business. But SharePoint Online, as it exists today, was not a real thing. And so in the past 3 years, we've made a massive investment. And we're now in 9 global data centers, about a $3.2 billion investment in data center and networking infrastructure. Our team runs over 13,000 servers, 37,000 SQL databases. We onboard 30,000 companies every week on average. And those companies run the gamut from a very large coffee company in the Northwest that uses our stuff, to government entities that live in our government cloud, to educational institutions that have upwards of 1 million users in our system. So we've grown by leaps and bounds, and we have 70 devs on call, 24/7 devs in the SharePoint product engineering team, not IT operations staff. And through that all, we've been able to meet and exceed our SLA. We've hit a 395 on average every month for the past year, and I think for the months before that. And we're also a global service. This was supposed to be a video. I had codec problems, but this is basically an Akamai capture of where we see SPO traffic coming from. And you can see that we've got traffic coming in from every continent except for Antarctica, which hasn't been a priority so far. But there's folks in Nigeria, there's folks in Kazakhstan, folks in Europe, Asia Pacific, Australia, so a fully global system. So what I want to talk to you about today is 4 main areas. I'm going to talk about how we achieve zero downtime, or at least strive to do so. I'm going to talk about how we keep your data safe and deal with disasters. I'll talk about how we keep a system of our scale always up to date. And I want to talk about how we're secure and compliant. As I said, a lot of this is going to be sort of behind the scenes, so I don't have a lot of demos to give you. It's going to be a bit of slideware. As you can imagine, I don't have the ability from podium machines in a casino to get to our back-end data center, which is probably a good thing for all of us concerned. And like I said, shout out questions as we go along. So let's talk about zero downtime. So, when we think about zero downtime, obviously from an architectural perspective, I don't know how many folks were at Duran's talk last hour. Were folks at Duran's talk on? Okay, good. So you got the deep dive on sort of the topology and the HA infrastructure and so forth. So we follow, sort of standard HA design principles, and I'll go a little bit later into disaster recovery and how we do that. But what I want to talk about today is really sort of how we do monitoring and telemetry, because really if you're not sort of monitoring the service assiduously, then you really don't know what the heck is going on. So when we look at our monitoring and telemetry goals, we really had sort of 3 main tenets. One was that you need to be monitoring from multiple angles. We started off using SCOM-based monitoring down at the component level. Are the machines working? Are the SQL servers in good health? But we find that that's really insufficient to understand really how the system is working. So we've expanded out into what we call scenario-based monitoring, where we're using synthetic transactions to track actual user scenarios end-to-end through the system. Because we don't really care whether that particular machine is dead. What we care about is when you browse the home page, does the home page load? When you execute a workflow, does the workflow load? Does the workflow execute? So we've invested heavily in scenario-based monitoring. And we've also started to really get into live traffic monitoring. So we're monitoring traffic patterns in real time to understand when we see network-level problems. So, for example, if we have an ISP lose a router in Dublin and we see traffic patterns from Ireland drop below what we expect them to be, we want to know about that, even though none of our machines per se is problematic. So the second thing that was really important to us was around driving accountability within the team. We felt very strongly that having a direct escalation model into the engineering team was going to be critical to us building the service in a way that would actually scale and would have the level of accountability that we needed. So in SharePoint Online, every developer and tester and program manager in the SharePoint team wears a pager. And so the folks on on Jared's base team that own the SQL infrastructure, those developers, they're on an on-call rotation, and when the SQL servers have a problem, they're the ones that get called because they're the ones that wrote that code, and they're the ones that can get in there and diagnose the problem most effectively, and they're the ones that are highly motivated not to get called again at 2 in the morning and fix the underlying problem. And then thirdly, and perhaps obviously, we had a real focus on automating everything. We are not going to be successful if we need to have an army of humans going in and doing deployments or going in and fixing up machines. So we've done a tremendous amount of investment at automatic diagnosis, automatic self-healing within the system. So let me talk a little bit about what that translates into from a numbers basis. So if you look at scenario probes, we're probing, we have about a little upwards of 70 different scenarios that we probe on every content DB, every couple of minutes or so. That translates to about 172 million probes of the system to see if something is going wrong. That's not counting the SCOM component-based monitoring that we also do. This is just sort of deep scenario-based monitoring. So that's a lot of probes, and as any of you who run a SCOM infrastructure knows, the level of noise to signal can get pretty outrageous. So today that results in about 600,000 what we'd call anomalies per month, so points at which the underlying monitoring system thinks something may be wrong. Well, obviously we're not going to call our guys 600,000 times a month, or they'd all quit the second month. So we've invested a bunch in a set of engines that go through and do alert correlation. So we have this thing called ACE, the alert correlation engine. We have another tool called Apex that deals with making sure that we're routing things appropriately. And so that as a result of those investments, that 600,000 goes down to about 200 Sev1 escalations a month. So about 200 times that I call someone in the SharePoint organization and say, hey, there's a problem right now, you've got to go and fix it. So that's about a 400% signal-to-noise ratio improvement. Still not as much as we'd like, but a huge improvement, and it keeps our devs from lynching me in the streets. But obviously, sometimes people do get called at 2 in the morning, and we talked about that direct escalation model. This is what they hear. No, sound guy, come on.
Online escalation system.
No, all right, no, I got to start it over, man. So this is what you'd hear if you were a SharePoint dev.
Hi, this is Ben Canning calling with an important message from the SharePoint Online escalation system.
Yeah, so they all hear my voice at 2 in the morning or 3 in the morning. It's been great for my reputation in the organization. So they're all getting, so when something goes wrong, someone on our team gets called. They get that call, and what's most important to us is to make sure that that developer has all of the tools that they need to understand what the problem is as quickly as possible and move to remediate it. So one thing that we've invested in is a thing we call smart alerts. This is an example of a smart alert. So this is a smart alert about a scenario of transaction failing. And the cool thing about this is that so the developer gets this on their email, and it's got all of the information about what time it was detected, what unit of capacity is impacted by the event, and so forth. We have an automatic link bridge set up, so everyone who needs to be on the call can click a link in this mail and get right on the call. We have a call routing system that will track you down via link, via messenger, via your cell phone, via your office phone, via your home phone, then your backup, then your we will find you and get you on the call, and then you click that link. But the really cool thing is that we've got diagnostics built into the smart alert right off the bat. So we have a whole system of automated diagnostics that run inside the data center, that run through the grid manager that Duran talked about last hour. And so at the second that escalation fires, before the dev is even on the call, we're off running diagnostics in the system. And you can kind of see here, this is the alert description here. And then we've already run a diagnostic, and we said, oh, okay, we actually know what's going on here. So we know that this issue is that these two CFEs, those are our content front-end roles, are not routing any traffic. And so that's your problem. That's why we're seeing homepage failures intermittently in this farm. And not only that, but these are the steps that you should take to go and resolve this issue automatically. So right in the mail, we've given the developer sort of everything that they need to go and take care of the problem. And then the other thing that we felt was really important is, so this is the developer going and using PowerShell to actually tackle this problem. And what the developer does is what we call a grid job to go and restart, in this case, restart a CFE machine in the data center. And the thing that you'll notice here is that this is a PowerShell command that the developer is executing from our internal corporate network. But the developer is not logging into production and rebooting a box. We've made it's very critical for us that as much as possible we want no one to have administrative access into the data center. So all of the things that you do in the data center from our perspective are automated scripts that we have auditing on, that we have role-based access control on, so that we don't have random manual things going on, but also I don't need to make anybody an admin in the system. And so at any given time, we typically have close to zero sort of standing administrative access into the data center. Which we think is very important for maintaining the stability and the security of the system. Sometimes, though, it's not as simple to diagnose the problem as all that. So we've made an investment in a bunch of cool diagnostic tools, one of which I'll show you here. So this is the SharePoint Analysis Studio, and basically the problem that SharePoint Analysis Studio tries to solve is that you've all looked at the ULS logs when you're trying to diagnose a problem in your farm, and you've looked at the usage DB, and the amount of information can be completely overwhelming. And then if you imagine sort of scaling that out to our farms, where in any given farm you've got multiple hundreds of machines, and you've just got oceans of log files that you've got to parse through, and so trying to ask a dev to do that sort of on the fly is really daunting. So what SharePoint Analysis Studio does is this is a tool that we built with Microsoft Research, and it parses through every ULS log file, And we can go in and say that, okay, it looks like our availability number for farm 1158 looks poor. Go and give me a comprehensive analysis of what's going on there. And when I click that button, it's going to run through the entire log file, and in just under a minute, it's going to come back and tell me, all right, it looks like up here we've got an availability drop for this period of time. And then more than that, it's going to go through and it's going to say, okay, well, here are the number of tenants and users that are actually impacted, so we can assess the scope of impact for this outage and get communications out to the impacted customers. And then we've diagnosed this, and we use a bunch of machine learning algorithms to detect patterns in the log files. And so we've gone through and we've diagnosed this issue. And it turns out that this is what we call a synthetic cookie refresh issue, which I won't get into the details of. But we've diagnosed that it's probably this CFE that's the problem. And so the steps that you should take, and here are some bugs that have already, that we've already found on this issue, and here are the steps that you should take to go and resolve this issue. So we try really hard to develop, sort of slick analysis tools, really all about keeping the developers productive and diagnosing problems as quickly as possible when they do occur. And so then, having resolved that issue, the developer and our live-side operations team can go back and look at our monitoring dashboard. This is the sort of the front page of our monitoring dashboard that we call SharePoint. We use point for a lot of things. We have lock point, and we have command point, and show point. And SharePoint is actually a SharePoint site running on 2013 that lets us use all of the cool SharePoint BI stuff and the workflows and so forth that you've seen demoed here at the conference this week, but use it to run the live service itself. We like to eat our own dog food, as it were. All right, so let me move on to the second topic. Sometimes you all are putting your mission critical data in our service, and while having downtime is bad, losing data is kind of unforgivable, and you all are betting your careers on the fact that we won't let you down here. So I wanted to talk briefly about how we keep your data safe in the context of SharePoint Online. One of the key principles for us is that we never want to have only one copy of any piece of data. So if you think about a user saving a file, that file is gonna hit a SQL DB on our back end, and so now we've got one copy of that file, and we don't have any redundancy. But actually, all of our disks are RAID 10 disks, so we actually have at least 2 copies at the RAID 10 level. So even if a disk fails, we don't have to worry about that. And then of course we're doing synchronous mirroring, so we've always got at least 4 copies with the mirrors. And one thing that the grid manager does for us is it ensures that we're always placing the mirrors on independent racks, so that we never have to worry about a single rack going down and taking out all copies of access to all copies of the data. And then, of course, we use asynchronous log shipping to ship the logs back to a failover data center. So that gives us a further 2 copies. So now we have 6 copies. And even if the primary data center goes down, we still have all of your data and can get you back up and running quickly. But we're also taking scheduled backups of your data every few minutes or so. So we always have several versions over the last 30 days of any piece of data that you've sent to us, which we can always get back to you. And we offer point-in-time restore for any of those files up to, I believe, 30 days. Jeff should correct me if I'm wrong, but up to 30 days. So the point being that we have multiple layers of redundancy to make sure that under no circumstances are we ever going to lose a file. And then, of course, the recycle bin for sites and files and site collections allows us to ensure that even if you've accidentally deleted a file, you don't typically have to call us to recover that file, although in some cases you will actually need to do that. So the way that our disaster recovery is set up, we basically use a hot standby system. So we have paired data centers, Chicago and San Antonio and et cetera. In both cases, it's an active-passive setup, but in both cases, those data centers are always both DR and live. In other words, we have live tenants where San Antonio is their primary and Chicago is their failover, and live tenants where Chicago is their primary and San Antonio is their failover. I think it's very important that there not be sort of second-class citizens in the disaster recovery space. Both of those data centers have to be live and monitored. We obviously monitor the system thoroughly. We look at data replication health and secondary farm health, and we do regular failover drills at least monthly in production to ensure that we can actually do what we claim to be able to do. And we guarantee a recovery point objective. Our recovery point objective is an hour. So that means that in no circumstance we ever lose more than an hour's worth of data, if, say, a meteor strike or an ag router failure. And our recovery time objective published is 6 hours, although in practice we find that it is significantly faster than that, particularly for read-only failures, which we have done live in production when necessary. So, in putting this all together over the last couple of years, we've had a couple of lessons that we've learned that I think are worth talking about. So I mentioned that we do drills, and I think this notion of drill baby drill is really critical for DR. DR is a complex process. And if you're not actually testing that you're really doing it and can do it in the heat of battle, then I don't believe you that you actually have a disaster recovery plan. And so we do this over and over again. We do DR failovers of grid manager. We do DR failovers of production tenancies. We do DR failovers in engineering dog food. We do it again and again and again. The second key point for us is that there can't be any second-class citizens. So every data center has to be a primary. And we don't have, less hardware over there than we have over in the primary. We don't have less monitoring. You really have to treat that thing as a first-class citizen, because when it's in the heat of battle, you don't want to have these questions about, like, well, can we handle the load over there? Are we sure that system is actually running happily? I think the third thing we've found that we really have to be careful about ensuring that we have resiliency both at the hardware and the software layer. So we find we've encountered challenges with disk failure rates. We use DFSR as our pipeline for doing the log shipping between data centers today, which is perhaps a design that we're going to move away from, but it's very I/O intensive on the disks, and so we've found that that disk failures in just the log shipping pipeline become a real danger to meeting your RPO commitment. So you have to be very cognizant of the SKUs that you're buying for your backup shares and et cetera, to make sure they can actually handle the load. But we also run into problems at the software layer. One interesting challenge that we've actually run into in production is when you're rolling out a patch. Do you roll out the patch synchronously to both the live site and the DR site? And in some sense, you kind of want to do that because you want to make sure that you have parity between your live site and your DR site. But we run into problems where you have sort of slow problems where, okay, now you've patched production and whoops, the thing in production broke something. Well, you'd love to fail over, except whoops, you've already patched the failover because you wanted to keep them in sync. So we've had to introduce a number of sort of procedural catches to make sure that we don't get ourselves into a situation where we actually are precluded from failing over because we've introduced the same problem on both sides of the wire. And then the last point is just the importance of self-service for us. We've made investments in not just the site, not just the document level recycle bin, but in the site and site collection based recycle bin. That really addresses in most cases of inadvertent data loss, which is actually the most common case. It's not all that common that we need to do a failover. The most common cases of unexpected data loss are your users deleted something that they then realized they didn't want to delete. But we still have a little ways to go here. There's a couple of places still where we allow you to shoot yourself in the foot. If you were thinking about going in and deleting your My Site, by the way, don't do that, because if you do, you'll have to call us to recover it, and it's a giant pain in the leg to recover it. But people do it all the time. Yeah. Oh, that's a great question. So the question was about what we call fail back. So if I have done a full failover to the DR data center and I've now lost the primary, how long does it take me to reestablish DR for the failover site? This is a tough problem that we don't have. We're not as good as I want us to be here. We would estimate about a week for us to get fully back up. The thing that's interesting is that the vast majority of cases where we see DR actually need to happen in the field, it's not the case that you actually lost the primary in any real sense. Data center fire is perhaps the most common case, but it's typically more that you had a fiber cut or you had an ag router go down or something along those lines. Like the primary is still there and still happy, and so it's really more a matter of reestablishing connectivity and then reseeding on the back end than actually having to move to Blue Ridge because Chicago has now burned down. And in cases of read-only failover, which are more common, our failover happens in sort of two stages. One where we just do a DNS flip to go read-only, and that's pretty much within minutes. If we see that Chicago is unreachable or a particular farm in Chicago is unreachable, we can pretty much fail over read-only in minutes and get you back access to the data, even though it's not read-write access. So better than nothing, but not, and that is sort of easily recoverable. And I would say that's the 90% case, is that like we have a temporary glitch in Chicago, we're going to fail over read-only, and then fix it, and then fail right back. The full read-only failover is one that happens far less frequently. So let's talk about always up to date. You rely on us to keep the system up to date. You want us to be fully security patched. You want us to have the OS updates deployed. You want the SharePoint QFEs there. You want us to be rolling out improvements on an agile basis, and we take that commitment very seriously. But on the flip side, changes in the data center are by far the most common cause of outages. And they also have some of the highest operational expense for us. And so finding the right balance between those two things is a critical thing. So we've invested fairly heavily in the Grid Manager to manage the orchestration of this. So Grid Manager has two components. One that is sort of the change manager, that's actually the workflow processing engine that knows how to go and make changes to the system. And another that we call Command Point, because we like funny names for things. But Command Point basically is the thing that knows what the state of everything is. So Command Point knows which virtual machines are associated with which farms, which virtual machines are on which physical machine hosts, and what all of the interdependencies are between those things, and which ones are being upgraded and not. So in the scenario where, so in the sort of most simple scenario where you've got two virtual machines that you want to apply security patches to, you have this sort of initial orchestration problem where, both of these virtual machines are in the same availability group. And so you can't patch them simultaneously because you'll lose high availability. So we have to know, okay, these two things are in the same availability group, so when we want to go and patch them, let's automatically lock VM2, so nobody touches that guy. We'll upgrade VM1, and then we'll lock VM1, unlock VM2, and terrific, now we're fully patched. So that's the simple case. It gets a little more complicated when you bring physical machine hosts into the picture, because now you've got physical machine hosts that are dealing with vMachines that are in different availability groups. So when you want to go and update the physical machine host, you have to know that, well, I can't update these two physical machines because the VMs that are on them are actually interdependent and part of an availability group. And if I do both of them at the same time, I'm going to take down a bunch of services. This is obviously greatly oversimplified because typically there's 7 or more VMs on each of these P-machine hosts. So the combinatorics gets pretty hairy. So Grid Manager sort of keeps in its head, okay, these are the P-machines that I can update in what order and so forth. And then finally, it gets a little more complicated still when you bring SharePoint farms into the picture and SharePoint farm level upgrades. Right? So you've got this sort of constant stream of patches that are going on for security and OS updates and so forth across all the P machines and all the V machines. Those virtual machines are part of different SharePoint farms. We have, I think, about 60 some odd SharePoint farms that we manage right now. And the vMachines are spread across the physical machine. So it's not that one farm is localized to a particular P machine, because for elasticity purposes, we want to be able to we want to have this giant pool of physical hardware that we can use elastically for different farms. So the Grid Manager knows that, okay, right now, farm number 3, that's all the green boxes. Farm number 3, we need to roll out the new build of SharePoint too. So we're going to do a farm upgrade. Well, if I'm doing a farm upgrade on those guys, I can't go out and do the virtual machine patching for security updates right now. So we got to lock all of those guys. And know that, oh, okay, P machines 5 and 8, those ones are okay, I can go and patch those. So we've got 15,000, 13,000 some odd machines that we're managing across 60 some odd farms across 9 data centers. And every month we need to be up to date from a patching perspective, from a security patching perspective. So you can imagine that the combinatorics of sort of managing all of that is rather complex. At one point we had humans trying to do it, and they would say, it's rather hilarious. They would sit in a room all day and go, okay, well, all right, that one's about to be patched, so okay, we'll do that one, and then that one is being upgraded, so it's running long, so let's move that one in, and it was this sort of giant jigsaw puzzle. Now we have software in Grid Manager that manages all of this, and we're able to patch the entire infrastructure and stay up to date on security patching in about 2 weeks. Sort of 2 weeks out of every month, we go through and do the rolling patches, which is pretty cool. So, but it also begs the sort of obvious question about, like, okay, so you're touching things all the time, and you told me that touching things is the thing that breaks everything, so how do you not break everything? Well, there's a couple of things that we do. So we use the sort of standard good IT practices. We have a change approval board that reviews all of the changes. Changes in the data center are automated wherever possible, and so in most cases we have an internal we either use WSUS or we have an internal patching tool for doing some things with SharePoint. So it's never that you've got an engineer or an ops person going out there and sort of fiddling with stuff. It's always a sort of well understood and code review process. But we also go through multiple phases of graduated rollout. So, the dev tests out the change on his dev box. We have a giant suite of automated testing that happens there. We have an integration environment that mimics prod in a small scale. The tests are validated there. We have what we call engineering dog food, which is sort of all of the folks in SharePoint and Office live there, and changes a lot. And so the changes then roll out to engineering dog food, and we see how it works there. And then all of Microsoft, all 90,000 of us, live in the Microsoft tenancy, which is a separate bubble. And that gets the changes rolled out to it next. So we're always sort of hitting graduated deployment, and we always hit Microsoft first. So if it's gonna blow up, the Microsoft farm is one of the biggest and most active farms that we have. If it's gonna blow up, it's gonna blow up on us before it actually rolls out to customers. And then in production, we do sort of a phased rollout, and we're able to stop and roll back as necessary. So let's talk about security. This is sort of the other. This is the other thing that for me is of critical importance. If you're going to trust us to host your business critical data in the cloud, you need to know that we actually know what we're doing from a security and compliance perspective. So I'm going to talk about four sort of key things that we do. So one thing that's critical for us is what we call nailing the basics. And that just means, like I was just talking about, making sure that we're fully patched, that we have all known vulnerabilities dealt with, and we do that on a monthly basis. And we have an entire security team for Office 365 filled with some pretty hardcore hackers that do penetration testing and red teaming on our system to make sure that we're covered here, and that are continuously scanning every one of our machines to make sure that our virus signatures are up to date, that we're patched for all known vulnerabilities, that all vulnerabilities that we can't actually patch through WSUS are known, and that we have a plan for addressing those. And so this is one of the reports that we get. And I'll just say for caveats, it's never 100% because it's always we were patching that machine and then they scanned it 5 minutes before, so you never quite get to 100%. But we feel pretty good about this, and so this is just sort of the table stakes, I would say, of making sure that that we are patched 100% at all times. Which, I mean, you're all IT folks, that's a pain to do. So the second big principle is secure by design, and really here we've invested heavily in role-based access into the data center. So if you're going to access a data center machine from the Microsoft corporate network, you're going to use a secure console that is locked down so that you're not browsing Reddit while you're fiddling with the CFEs and so forth. So that's thing number one. But thing number two is we manage permissions into the environment very closely, and we use an on-demand access model where, in general, no one has access into the environment. No one runs as admin. This isn't 100% true, but it's about 90% true and getting closer to 100% true every single day. There's still some things where we need admin access into the environment to do things. But in general, our view is that the admin, should have access to core data. Our folks should have access to workflows and logs that we need to do debugging, but we don't need access and shouldn't have access to your data unless you explicitly give it to us because you need us to go in and understand a problem. So in general, we don't have standing access, and we have the ability to sort of escalate on a per incident basis if we need to get that access into the data center. And we also have the ability to control this on a per environment basis. So for example, in the government cloud, only US citizens are allowed to do debugging on that environment. So there's a subset of our operations team and actually a subset of our engineering team that can actually go in and do admin level activity on that environment because we don't allow non-US citizens to access it. So the third thing is we have to be able to prove it. And so we have done a tremendous amount of work to gather a wide range of US and international certifications for our security posture. We are ISO 27001 certified. We're one of the only online services that has signed the EU model clauses on data privacy. We just recently announced HIPAA. We are FISMA compliant and are on the way to being FedRAMP compliant with the 2013 release. For any of you that have had to deal with going through these kind of third-party external audits to get, ISO certified or FISMA certified, it's not fun. And I'll tell you, the developers that work on SharePoint really, really wish that I would give them, debug level access into the data center because it makes their lives much, much easier. But we're pretty serious about this. We'd rather make sure that we build the tools so that we don't need that level of access, and we can meet these rigorous standards and pass inspection by third parties so that you can be confident that we're doing the right stuff. And then the fourth one, which is I think the coolest and most fun, is that we abide by a philosophy we call assume breach. And that philosophy is basically that we can do all the good stuff. We can be FISMA compliant, we can be up to date on our vulnerability assessments, or we can be up to date on our virus signatures and so forth. We have to assume that an attacker has gotten in at all times, and we have to be looking for the traces of what that would look like. So we do proactive monitoring of the system to detect process launches, to detect network activity that looks suspicious, to detect accounts that shouldn't be there, so that when something suspicious looks like it's going on, we're able to rapidly detect, yeah, that doesn't look right. And one of the things, so what you see here on the screen is an example of a report showing process starts that are odd. WinDiff.exe is actually not all that scary, but it's a little bit weird, that it's happening in production. And so this is, who did it and where they did it and what they did. And the cool thing is that this all ties into a massive big data system that we have that we call Cosmos. And Cosmos allows us to gather multiple terabytes of log files every single day and pump them into a big data store and do interesting things like security log analysis in a proactive way, for example. And Cosmos is pretty cool. It's the same system that Bing uses, the same system that Windows Live uses. So we upload multiple terabytes of data into it a day. But again, sort of keeping to our promise around access to your data, we have built comprehensive PII scrubbing. So we have a scrubber that scrubs out any customer identifiable data from those logs, so that what's going into Cosmos doesn't say anything about the name of your document or the contents of your document or anything that the auditors deem we shouldn't be allowed to see. So that allows us to do the process monitoring that we want in real time and over massive scale data, but allows us to ensure that no customer data is actually ever leaving the data center. So again, this principle that we want to enable our engineers to manage the system and keep it healthy, but without granting them access to any customer data except where absolutely unavoidable. So Cosmos lets us do a couple of cool things. This is an example where we can query correlation logs in under a second across every ULS log that we have ever seen in the last 3 years using the Cosmos system. You punch in a correlation ID and it pops out every instance of that correlation ID. So it's a great tool for debugging, and obviously we also use it for business intelligence reporting. So for example, this graph allowed us to see that IE7 usage was about 3% of our traffic. And so that allows us to shift our whole engineering process towards a much more data-driven process where we're actually looking at what are people really doing on the service, and are the changes that we're making improving things or not improving things, making things better or worse, and we can guide our decision making on the basis of that. And with that, so this is the SPO Command Center. I promised the guys that I would give them a shout out at SPC. So, in addition to all this cool automated monitoring that we have, we have a set of folks that they're in Building 16 at Microsoft, right next to all of our offices in this command center, 24 hours a day, 7 days a week. Doing proactive monitoring, making sure that the system is healthy. They're the folks that know how to do things, that are already awake when you get the call at 2 in the morning, and they do a great job. And we built this command center fairly recently because we really wanted to situate it, at the heart of SharePoint development, so that everyone in SharePoint is seeing the command center every day and really feels the pulse of the service, and it's been a great thing. So that's the command center. Yes, we do let them have coffee in there. But access to, actually, it's funny, they have their own little coffee, one of those Keurig things. It's actually a nice little place. It's also nice because it's secured access. So it gives us a place where we can control who gets in there and who can actually sit down at a kiosk machine that has data center access, and we know exactly what's going on. Yeah, it's a good thing. All right, so that's actually all that I have. I got through that faster than I expected, but I think that's good because we got to go to Ask the Experts. So please evaluate the session, and I'll open it up to Q&A. Thanks. Questions? Yeah. So, sorry. Yes, 13,000 servers. Yeah, we do. We have actually Zach is hiding over there, is one of our key capacity management folks, and I don't know if Kafir is here as well. But yeah, we have a planning effort underway to well, actually, we have the 2013 topology in place today. We're actually in the process of upgrading all farms to the 2013 infrastructure. But yeah, we have a sort of constant process of refining what the topology needs to look like. I would say in the beginning of SharePoint Online, we really overbuilt, as you do, because we would rather have had too much hardware than have too little. So I would say, we overbuilt the farms relative to what they probably need to be. Each one of our farms we can host about 100,000 tenants on, and they're probably they're too big, and so we actually are continuously looking at what's our plan for scrunching those down. And of course, as we do that, we'll that topology guidance will roll out to you all about, okay, well, this is how we're doing it in the service, and this is how we would recommend that you do it on-prem. I think that's it's sort of a side point, but one of the best things about us running the service, from that perspective, is that all the stuff that you have had to deal with for years, like, boy, the SharePoint SCOM pack is really noisy and lame, and all the things that we said, oh well, the IT guy will figure that out, it'll be fine. Like we're now figuring that out and feeling that pain, right? I've learned, more than I ever wanted to know about keeping SMTP servers healthy, because I need to keep the alerts and the workflow and permissions mails going out. So we're, learning a lot about that, and I think you'll find that the SCOM pack for 2013 is a lot better because we we desperately needed it to be, and then over time, you'll see that SharePoint becomes a lot easier to run and manage. Though, of course, I hope that you will just give the problem to me to deal with. At least that part of it. Yeah. 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 So the question was about how many, was sort of okay. Can you tell me a little bit more about the topology of the farm and how it's set up? And do you have sort of different farm structures for different workloads? The answer to the second question is no. We basically have a single farm stamp that deals with all workloads. We actually think this is sort of a core design principle that you really want to interleave the different workloads, and sort of with the law of large numbers, you end up with a fairly even distribution of load within the farm. And also, it's just very hard for us to know for a given tenancy how are they going to use use SharePoint? Are they going to be heavy search or heavy collab or what? In terms of the actual makeup of the farm, generally speaking, the farms are all the same, though we have some variations within them due to various specific circumstances with how much space there was when we built out that farm and so forth. But generally speaking, we have one sort of stamp. Although Zach can go into much more detail about the actual farm topology. It's funny, I actually had a slide on it, and then I was like, oh, I'll never get to it, and it'll be. So do you want to talk a little bit about the farm topology? Find Zach afterwards. He can give you the deep dive. Yeah, over here. Yep. Yeah, so the question was, hey, all those tools that you just showed, those would be pretty useful. Can we have them? We actually thought that was going to be the first question, so I'm impressed we made it to question number 3. Yeah, absolutely. We've really focused on, for the past couple of years on, getting the service itself up and scaled and healthy and sort of building these things, and have focused less on how can we turn this around and make it more generally applicable. But absolutely, we think that a lot of these tools could be very useful, and I think. I can't make any commitments, but I think down the road it's definitely a thing that we would like to make available. It's a little bit challenging in some cases because a lot of them depend on aspects of our infrastructure that are not sort of easily carve outable. But SAS, for example, the Analysis Studio tool that I showed you is one where you could potentially carve that one out. There's a few others. We've also toyed with the idea of turning the scenario-based probes that we run, that I talked about, the homepage evaluation and so forth. Those all actually run in Windows Azure, and so in principle, there's no reason why you couldn't take those and point them at any on-prem SharePoint farm, right? Open up a port, and we'll monitor the snot out of your farm, and we'll let you know when we detect a problem, and we could just host that as a service. So it's something that we've toyed with, but I don't have a timeline for that. Yeah. Can you? Hey, can we get the lights up, maybe? Or at least turn that one off. So the question was, oh, that's a good idea. Without downtime. Yeah, the question was, can we patch SharePoint 2013 without downtime? Yeah, Duran went into this in exhaustive detail in the last session, so you might want to get that. But yeah, the short version is, generally speaking, yes. What we do is what we call a swing upgrade, where we effectively build up a target farm and get it all ready to go, and then we do a DB attach and flip over. So there's a brief flip period, but not downtime. Oh, whether you can do it? Yeah, you should in principle be able to do. I'm not the upgrade expert. You should in principle. Yeah, I mean it depends on the patch. So there's Sean. Woohoo! Okay, I need to stop talking. That guy over there, Sean Livingston. Oh, go to Ask the Experts and find Sean Livingston, and he will tell you everything that you ever wanted to know about upgrade, and more. Yeah, over here. Question is, how are we detecting and protecting against denial of service attacks? We have anti-DOS hardware at the network layer, and our network infrastructure is just it's pretty big, and so it's actually that is run by there's a core Microsoft group called GFS that runs our entire network backbone. And so they do a bunch of work to make sure that we have sufficient capacity. We're also starting to, we do use CDNs now, and that allows us to immunize ourselves to some extent. So the question was, okay, you're well protected on the back end. Do you do anything to protect against data leakage on the user side? A lost device or something. I mean, I don't think that we have anything that goes beyond what you'd have on-prem in terms of that. We might be able to detect. We do detect some forms of aberrant user behavior. So there, from time to time, someone will try to use us to host a spam site or host phishing attacks from us, and we're getting pretty good at detecting when that kind of activity is going on. But yeah, if a credential of someone at your company gets compromised, I don't really have any good way of detecting that. Two-factor auth would be one way of improving that, which we don't yet support. Anybody else? Yeah. Uh-huh. So the question was, how often have we had to do a real disaster recovery failover with real customer data? It's in the, I would say it's on the order of, 3 or 4 or 5 times that we've actually had to do that. It doesn't happen very often. Yeah, same. Apparently, I need to stand back up here. Yeah, so the DR side is the same equivalent hardware. The one thing that we don't do on the DR side is while it's in DR mode, we don't have mirroring established. And so one of the things that we do when we actually do the full failover is, what part of that sequence is to establish mirroring on the DR side and get that caught up before we do the flip. But other than that, the hardware is all the same.